again, you guys. Can you believe it? I'm wearing the same outfit as I was when I did the previous video. Oopsies! Don't worry, Mrs. Fox. You look great. Thanks. I decided to do 2 videos in one day just because I could. I know. Using my time wisely. I thought it was a really good idea. Let's jump right in and review our last unit of information that College Board has asked us to be responsible for our AP exam. I'm super excited. Okay, so you will notice that what I'm doing right now is Unit 10. Ladies and gentlemen, that is because I did not mess up, okay? That is because College Board has skipped the material from Unit 9, okay? They are asking us to still be responsible for it, like they want us to learn it, but we don't have to be tested on it, and that was the stuff that we ended up with: polar, parametric, and vectors. So they still want you to know it, and we covered it, and we did a beautiful job with it, but they're not going to put it on the AP exam that we'll be taking on May 12th, okay? And also, this Unit 10 is about our sequences and series, right? What we did in our chapter 10. And what this is going to tell us is that we're actually only going to cover some of the topics. They went ahead and lessened the amount that you had to be responsible for, but you still have to know a handful of particular things, which actually I think is just like super exciting for you guys, because you can like narrow your focus and really hone in on these particular things. So I think this is actually like the best news ever for you. Like, a round of applause for College Board. Okay, so let's go ahead and jam out these topics right here. So literally, you're only responsible for these 5 things. Okay, so there's only 5 things that you're responsible for, and yes, they do skip around, but that's what they wanted to do. Okay, and so one of the things that they're going to ask you to do is be familiar with geometric series. Okay, now this goes back to our pre-calc days, so hopefully we'll be golden. You need to be able to recognize what a geometric series looks like. There might be some sort of a constant in front, and then you're taking a number and raising that number to the n power. Okay. As long as the absolute value of that number that you're raising to the power is less than 1, you can go ahead and find what that geometric series sums to, and then it will be a convergent sequence. Remember, if your value is greater than 1, it will be a divergent sequence, right? Divergent series. Sorry, too busy pushing the sound cue that I messed up my words. So sorry. Just kidding, guys. Okay, here we go. I'm back. Okay, well, they're going to ask us to also be responsible for the harmonic and P series. Now, remember, a harmonic is actually just a special form of a P series. What does a P series look like? Okay, a P series looks like 1 over n. This number is going to be just a 1 over n, and then this is what we're interested in, what that is being raised to. Okay, so like, it's different than a geometric. In the geometric, that the n value is in the exponent. In a P series, the n value is on the bottom of the fraction, right? So you really want to think about the difference between those two. So on a geometric series, it converges when the absolute value of r is less than 1. On a P series, you want to make sure that the absolute that the p value is greater than 1. Okay, so you want the p value to be something like a 2, a 3, a 4, even like a 3/2 would totally work. But you just want, yeah, it's the opposite of the geometric. And so just kind of like keep those in mind and try not to confuse up those two. Okay, they're asking us to be responsible for the alternating series. So how do you know if something is an alternating series? Well, you actually might have to try some of the numbers. A good hint is if it's like -1 to the n power, or -1 to the n plus to the n minus 1 power. Those are like 2 ways. They can also disguise it by doing like a sine or a cosine of like certain multiples. So a good one on this, a good tactic is to write out some of the terms, and just to see if it really is alternating. And then what does the alternating series test ask us to do? It asks us to do sort of like prove 2 things. Is your function decreasing? Like, is each term getting less than the previous term? And are those terms, just the terms, without the alternating part, like just the regular part, are those terms going to 0? If you can check mark both of these, okay, then you know that series will converge. If any of those do not work, like, so say like the limit goes to 1 or something, then you're like, nope, it's out. it will in fact diverge. Okay. One of our favorite tests, because it was so handy and like so amazing. Yeah, I'm just going to give it an ooh already, is the ratio test, right? So the ratio test allowed you to take an n+1 term over an nth term. And they basically want you, if you can get the absolute value, little traffic on my street out there. Hope they're having a good day. If you can get the limit as n approaches infinity of this expression, your n+1 term over your nth term, the absolute value, if you can get that to be less than 1, then boom, that baby totally converges. Okay. They're also going to ask us to find Taylor polynomial approximations, and we spent so much time learning about these. You have to remember the pattern for each of the terms, right? So each term's coefficient has a certain pattern. It's the derivative, right, at the center over the factorial, and then times that x value or the x minus a value to the same power. Remember that we can center them at 0, or we can center them at a number like at a, and then you would just be raising, you every time you do your powers, it's going to be x minus a, right? And then it's going to be to your power up here. Okay, so that's going to be what you're raising it to, and then of course you would have your coefficient in the front as defined by that guy right there. Okay, and that's how we can build our Taylor polynomials, and we can use them to approximate functions that are close to that center, not far away, but close to it. Okay, guys, that was the only things that they asked us to find and be responsible for Unit 10. So you are, again, going to do 3 free response questions. You are going to answer them diligently. You're going to try your hardest. You're going to score your work. You're going to say to yourself, oh, I was supposed to memorize that. Let me put that in my list of things that I need to know better. Okay. And that will finish us out for the week. So ladies and gents, that's about it. Okay. I want to wish you well as you do your free response questions again. I'm very proud of the work that you guys are putting in. I just want you to continue. It is all about you passing this AP exam, and we have worked so hard. I want you to do it, right? I want you just really making those your math powers super, super strong by the extra practice. So I'm very proud of you. I miss you. I hope you're doing well. I hope you're staying safe. I hope you're keeping busy. I mean, I'm providing you lots of work to do, so you should be very busy, but also getting in that relaxing time, but not too much relaxing time. No, definitely not too much relaxing time. So ladies and gents, I think that's it. Let's get some fanfare music to bring us out of here, and have a good day. Bye.